Bismillahirrahmanirrahim. My name is Muhammad Shoaib. Welcome back. Today in this tutorial video, we will learn what is a SCL and how we can use in the PCS7. SCL stands for the Structure Control Language. It's a high-level text-based programming language used in the Siemens automation system. It based on IEC 61131-3 standard which define programming language for PLC logical controller. Unlike logic or function block diagrams, SCL is written in text format similar to programming language like Pascal or C. This make it ideal for the complex mathematical calculations, data processing, and implementing advanced logic in your automation projects. In PCS7, SCL often used in CFC charts and standalone programs to handle tasks that require precision and flexibility. SCL is written in the text format, make it easy to read, write, debug logic. As SCL excel at handling complex calculations, make it perfect for tasks like process optimization and data analysis. You can use loop, condition statement, and functions to create a modular or reusable codes using the SCL. SCL integrates seamless with PCS7, CFC, SFC editor, allow you to combine it with other programming languages. SCL is compiled into machine code, ensure fast execution in your automation system. These features make SCL a go-to choice for engineers working on advanced automation projects. So in this tutorial video, we will learn how we can configure SCL in the PCS7. In one of the example project, we have two motors. One motor is working as a duty, another is working as a standby. If the first motor is tripped, then through SCL logic, it will automatically control shift to second motor and that will start automatically. And these motor is controlling both of the motor controlling with the tank level. For example, right now the tank level is high, so that's why motor is stopped. If level goes down, then our motor will start. If level go below then 2, the A you can see the motor is started now. And if the first motor is tripped, then control shift to second motor. So let's see how we can configure this simple logic in the using the SCL. So this project we already created in our previous tutorial video. So we will use the same. So configure the SCL. So first we'll go in the source and then right click here and insert new object and click over SCL source and right click rename. I will rename the file name SCL auto logic and double click and open it. So our SCL editor is open now. So click here insert, then block template and click over the function block. So we can like create a function block or FC. For in this tutorial, I'm creating a function block using the SCL. So here you can see automatically the function block script is came. So here you can write any of the function block, for example, function block, anything you can. And after save and compile, it will automatically generate it here in the blocks, that relevant function block. There is a one method. Another second method is you right click, insert, and create a one any of the function block. For example, I will create it and I will write the name like SCL Autology. Okay, click OK. So in this case, you will just uh, write the same name, copy, and you will replace here the same name. So in that case, it will also work. Any of the method you can use it. Okay, and after that, I need in already in the function block, we require some input and output parameters for our function block. So I will again go back here insert. But before insert, you have to click it here. Before the function call block, click it here because I want to add here the variable input variables. Insert, then block template, and then parameters. So here you can see for my project, I require input and output parameters. So here I will also open my previous logic in the previous tutorial for the customized logic using the function block. We already developed it. So same logic now previously in the previous tutorial we developed logic in the function block. Right now same logic we will develop in the SCL. So here you can see in our previous tutorial we developed these all logics, and I will put it parallel to this. Okay. So here as you remember we configure input interface, output interface, and then state interface we configure. So I require also here just input output not required. So delete it. Then output parameter I needed, and then this temporary variables not required. Okay, and that's it. Okay, so now I will just remove this comment and I will add the input parameter. I will come here, I will just copy. So I'm going to develop the same logic, so I will just copy the same tags, boolean. Then I will again copy the second tag. If you did not saw the previous video, I will give in the description. You can watch it how previously we develop a customized logic using the function block. So trip tag I will also copy, boolean, and similar level copy, and then level high copy. Okay, our input interface is completed now. Now I will go here in the output interface. I will just copy the same tags name. pump 2 run, then pump 1 trip, okay, then pump 2 trip, okay. Now last one more variable we have to configure, right click, copy, okay, perfect. Now like I will here start my logic, I will remove it and I will write begin, and after that I will start the my logic. So in the first I want to just the network one. So here I will put the comment same as network one we created. So here you can see right now we will put the some if logic. I will remove it. Okay, here again come in insert control structure and select the if. Okay, and here we require only the if condition. I will remove other all statements. So I will remove it, and here what I want, if this level status this low level, upside we have the low level, if the low level I will copy it. Okay, if the low level is equal than true, then what I want, I want this low status should be true. Copy, then low status is equal than double dot equal than true. Okay, so here you can see here if this bit is this contact is true, in that case is just put the continue set the value. Here also we are doing the same, and I will just copy it, and for network 2 we also do the same thing. Okay, so here you can see we need level high tag, and we are putting like reset means false. We are putting the false value. So I will copy it from here upside, control C, copy, and if the high tag value is true, in that case I want to put false value, or I want to write a false value in the level status. So if the level is low, that means this bit will become true, and if the level is high it will become false. And here in the next we are using the same one. So now we'll create same logic here that we already created in the ladder language, same in SCL we will develop it. So I will write copy, put network 3. Now here we also require like if else state. So I will go back insert control structure if. Okay, so here I will just delete this, and I will delete this. Okay, so now here we'll add some complex, little bit complex logic. Okay, so first is we have to compare either this level status value is true or not. So I will copy it from here, level status. So level status is true. Okay, and after that I will use AND function. Here you can see two of the AND function is there. Then the duty selector switch 1. So I will go up. I will copy this tag, copy, and I will put it here, is equal then true. So if this is true, then I want this trip feedback tag as a false. So I will put one more and I will copy it from here, the same tag. So here I will put the false value. Okay. Um, Either I can there's two methods. Either we can put it false or what I want, like I can put it or not, and I can write it like that, and here I can true. Okay, it will invert the true value, and I needed this NC. Okay, so here I'm using just not. Okay, so it's mean it will invert the whatever the result is coming here. Okay, after that, now this whole path is completed now. So level status, duty status, and common trip feedback. So if I will write only this one, so then if this all is this one level status and duty selector is came, then it will run the pump. Okay. Suppose I will write the logic here, the pump one run, copy, pump one run. I will write the value 2. Okay. But I also want like this below logic also incorporate. So what happened? I will first put AND function for level status, then duty 2, then pump 2 feedback, and after that we'll use this and then we'll write. So how we can add it? Like here we can consider this one is a one function, like whole of them. I will put the bracket here and here. If this result came or one more result came, okay. So in that case, like this same function will copy it here, okay, and then I need DT2 switch. I will go up. I will copy it here, copy DT2 switch is equal then true, okay, and then one more AND functions, and I need this pump 2 trip feedback. I will copy it from here, pump 2 trip feedback. Yes, copy it and come down here and is equal then true, and same this trip feedback here I already created. So I will copy it again, copy and. So here you can see this level status, this one, and after duty selector 2 also and then pump 2 trip feedback also and after that one more and then I put in not function. So if the pump is tripped, it will not allow to run the pump 1. Okay. Okay. This is for my network 3. Now I will just convert ladder network 4 ladder language SCL. So I will write it, just copy and I will paste it here like 4. But before, like I want if this true upside condition is not true, in that case my it should write actually false value here in the pump. So I will write it false. Okay, perfect. So now here I can also write, like I can insert logic if conditions, and I can remove it this and this one also. Okay. So here, like uh, this is a one method. Here I will use another method. Like I will create here one of the variable. Suppose p02 p02 status. Now I will create a this tag and copy and then paste it here, and then what happened, I will just copy this complete one and I will modify. I will just modify it. Copy, paste. Okay. So I will just modify this one, and what happened, what I will do it, I will just copy and I will put it here. Okay. And if the value is equal than true, okay, then I want like the form2. If the value is true, in that case I just want to write true, and else I just want to write false. Okay, perfect. Okay, so here I will write this network 4. Okay, here we can see the first is level status, then second is a duty 2. So here I'll just modify with 1 and 2. Then it's showing the pump 2 trip. So here instead of 1, I will write the 2. So here is the, this one is okay. This is the same network for the first line. Then we'll move second step. Same, it will follow the level status. Then it will go down. Then here duty 1. Then it will check the pump 1 trip feedback. And after that, it will check the pump 2 feedback not valid. So that's it. Now I will go down. Here is our last network 5. Just copy it. Okay, here network 5. So network 5 is like is related to motor trip. So here we will also use the if condition inside logic if, and here we also no need if else, and I will remove it. Okay, so here the pump 1 trip, if the pump 1 is trip, if pump 1 is equal then false. Here you can see I use the not. Wherever we are using not, you can like use the false. And what I want, like yeah, that is, sorry, here we have to use the pump 1 trip feedback. Once the trip feedback came, so we have to feedback, right? And after that, we have to write value in the trip is equal than true, and same we can copy it and we can write it false. Okay, so same I will copy it and paste it, and I will just change like pump 2 feedback and output also the 2, and here also the 2. So we'll save our this, and after that everything is perfect. So now we'll compile our SCL logic. Click yes. So here you can see we are getting zero warning, zero error. Okay. So here this is our complete configuration without error. Okay. So it's compiled now. Now I will close it, and I will also close this one. So here is our FP that we created with SCL logic. Now I will come here mixer, and I will open my motor logic CFC. So our motor logic CFC is open now. Come here in the blocks, then mixer plant, then here you can see SCL auto logic function block is there. So we already created this channel input driver in our previous tutorial. So I will select it SCL auto logic FP2 and select and drag and drop it here. Click yes. Okay, now we'll click here EV out with duty 1 here for duty 2 and for trip uh, for 1 trip, and this is for the pump 2 trip. Okay, now the level we have to connect it. Come here in the level area, open the level CFC. So click here on the level high, then go Windows, Motor Logic, and click here on the level high pin. Now click here level low and go in the level area and click here the level low. Okay, go back in the Motor Logic area. So here input side we already configure everything. Now we'll configure the output side. Go in the PUM1, open the PUM1 CFC chart. Okay. Now the auto start, click here and then go back in the motor logic and click over the run. Okay. Click again here, same run, go Windows and then PUM1. Now in this time we'll connect with the stop, auto stop. Okay, run right click over stop auto and invert it, because once the start bit came in that time, here one should be at that time, here it will invert and it will give the zero value. So it will just invert it. Once the stop is here zero value, then it will invert and the true for the stop. Okay, so go back in the motor logic, and this time we click here in the pump 01 trip pin, output pin, and then Windows, then pump, and click here in the trip. Okay, go back, motor logic. Now our for pump 1 linking is completed. Now we'll move for the pump 2. Go pump 2, open the CFC chart for pump 2. Okay, Now click here in the start auto, goes window, motor logic, and then click here motor 02 run. Okay, now again click here form 2 run, go windows, form 2, and click here over the stop. Okay, then click over stop auto, right click, invert it. Then click here in the trip, windows, motor logic, and click here over the trip. Okay, so our SCL that block or logic we created using the FP, that that block is linked with all of the inputs and output. Now I will just simply close it, then come here in the chart area, right click, PLC, and we have to right now first compile it. Suppose entire program. Okay. Here to close, then right click, PLC, download. Okay, click OK. Yes. Click yes. Okay, click over the close. Then open, right click, open the object. Okay, and after that, just run the project. Our runtime is open now. Click over the mixer. Okay, you can see our motor cannot start. So I will open the wall. Open, click OK. Here also click over the open. Okay. And put motor in the auto mode. Here you can see interlock is healthy now. Put in the auto mode. Here also put in auto mode. So I will on the duty selector switch. Here you can see once the duty selector switch is on, my motor is running. And now if I will increase my level, suppose my level goes to 3.7. So still my motor is running. If I will increase level above than 7, so now my motor will become stop. Similar manner, If I'm going down, suppose 4.1, still my motor is stopped. But once the level, here you can see, if the level is below than 2 meter, then it will become the stop. So if I will open right now my mixer, motor logic, to go in the test mode. Okay, then click here and then watch on. And after that, press the control key and click over one by one over the input and outputs. So here you can see right now, no duty level is coming and no any pump is running now. So now I will like I'll reduce. I will go down more than 2 meter. So you can see now my pump is started, and here also you can see the pump one run is coming and low level value is coming. So now go back. Now for suppose I will trip this pump. So once I will turn on, so you can see now my pump one is tripped now and pump two is started. Here you can also see the pump one is tripped and pump two is started. Is trip feedback received from the field. And if right now if you click it here, this will not if this reset button will not appear until it's not trip is not clear from the field. Once it's clear from the field, then this trip reset is appear. Then you have to click it here and you have to click OK. So now the pump one will automatically start again. So Alhamdulillah, we learn in this tutorial video how we can use SCL to configure the customized logic in the PCS 7. So thanks for watching this video.